Hello and welcome to today's class. We are going to look at determinants of 2 by 2 matrices. So before I continue with this class, I want to emphasize that we can only find a determinant for a square matrix. Okay, so the only time we are able to find a determinant is when we are dealing with a determinant which has a square order. So 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6. But at this particular level, I'm only going to handle determinants of 2 by 2 matrices. Of course, as you continue, maybe in higher level, we'll be able to handle determinants of larger orders, let's say 3 by 3, 4 by 4, and etc. So anyways, so first of all, you want to make sure that before you determine a determinant of any matrix, it has to be a square. And that is why at this particular level, we are only dealing with a 2 by 2 matrix, which actually happens to be a square matrix. Then another thing I also want to say that when we are talking of determinant, let's say you're given a matrix A, B, C, and D as the elements, then we will always, first of all, want to treat it in its absolute form. So basically, it will be the absolute matrix of A, B, C, and D. And so, if you're going to determine the determinant, this particular case, you want to multiply A and B, all right, A and D, all right. So it's going to be A times D minus, okay, C times B minus C times B. And again, you want to take the absolute value of whatever you'll find there. All right. So the difference of A times D and C and B is what we call a determinant, is what we call, and it has to be the absolute value, is what we call a determinant. So that is a statement that I want to make concerning determinants. And also, I want to say that when we are looking at determinants, we're not looking at it as an independent concept. We are looking at it as a concept that helps us to calculate inverse of matrices. We are looking at it as a concept that helps us calculate inverse of matrices. So basically, an inverse is a reciprocal, all right? So for example, if you have, let's say, the number 2, the inverse of 2 will be a half. The reciprocal of 2 basically we have. So matrices also have reciprocals, and we cannot find reciprocals or inverses of matrices unless we know how to calculate determinants. And that is why we are looking at determinants in this particular class, of course, as a build-up to being able to calculate inverse of matrices, which is a very important concept when we are trying to solve linear simultaneous equations. All right, so why don't we go ahead and dive into an example that is actually trying to find a determinant of a matrix. Or yes, so find the determinant in A, where we are having a matrix 2 by 2. We're having 3, -2, 5, and 0. And of course, B, 4, -3, -2, and 7. So what is the determinant in this particular case? As I already said, you want to take the absolute values of these numbers. But anyways, we are going to, in this particular case, multiply the elements in the main diagonal. Now, what I didn't tell you is that these elements that are slanting diagonally, all right, in this particular matrix, that is 3 and 0, actually happen to be in what we call the main diagonal. All right, they happen to be in what we call the main diagonal, or you can also call it the principal diagonal. All right, principal diagonal. So you can call it the main diagonal, you can call it the principal diagonal, and you can also call it the leading diagonal, and you can also call it the leading diagonal. So when you are calculating determinants, remember, we take the products that are in the main diagonal, all right, of course, or principal diagonal, or leading diagonal. So basically that's going to be 3 multiplied by 0, okay, and we subtract that from the products of the other diagonal, or we also call them the secondary diagonal, that is 5 and negative 2. Okay, and the product of that. And so that's going to be 5 times negative 2. All right, and remember that determinants require that we take the absolute value of whatever we're going to get here. So basically that's going to be 3 minus 0 times 0, giving us 0 there, minus 5 times negative 2, giving us negative 10 right here. All right, and so this is going to leave us with 0, negative times negative 10, which is basically 10. All right, so there, of course, and it has to be the absolute value of that, and so that therefore means that our determinant is going to be equal to 10, and so we can leave it at that. So that is going to be our determinant in this particular case. So the same thing that we've done here is what we're going to do in B here, where we'll be multiplying the elements in the main diagonal, which in this particular case, I believe, will be 4 and 7. So we're going to take 4 times 7 minus, all right, 4 times 7 minus negative 2 times negative 3. So the elements negative 2 and negative 3 belong to the other diagonal or secondary diagonal. All right. Right, of course, we are going to find the difference of these two, and whatever value we get, we will take the absolute value as the determinant. All right, so that therefore is going to leave us with 4 times 7, giving us 28, minus 2 times negative 2 times negative 3, leaving us with positive 6. All right, so basically this is 28 minus 6, which is going to give us 22. And whatever the case, we are always going to take the absolute value. So absolute value, for those of you who do not know, is the positive number. If it was, let's say, a negative number, we would have treated it as a positive number. All right, so the absolute value here is 22. So we don't have to do anything anyways. So this here is going to be the determinant of this particular matrix. Okay, so those are enough examples. Determinants of matrices are that easy. You just basically have to take the product of the elements in the main diagonal, all right, minus the product of whatever elements that are in the secondary or other diagonal, and you have to take the absolute value of that difference. Okay, you take the absolute value of that difference. So see you in the next video, where we talk about inverses of matrices, which is actually a concept that requires knowledge of determinants of matrices, of course 2 by 2 matrices at this particular level. Thank you and have a wonderful day.